Hi guys, this is part 1 of my cloud course on this YouTube channel. So, as you've seen on my channel, I've been taking a long break from gaming videos, and there's a good reason for that. I just wanted to clear up some confusions and other mis con- confusions and things I struggled with when I was starting in this field of networking in IT. So this is going to be the first part of the first video in the series. It's going to be an introduction to cloud and what it is and how we can define it, and also what the characteristics of cloud are. Now, first you may be asking me, well, why should I care about cloud? It's not going to affect me a lot, is it? Well, you may have noticed recently in the news and in other YouTube channels that large companies have been embracing cloud technologies and gearing their own software and hardware towards using cloud. And the reason this is because it benefits them a lot and it can benefit you just as much. So before I get into everything and the nitty-gritty about this course, I wanted to quickly tell you a few things so you can get the most out of this course. First off, what I recommend is for you to make notes and make lots and lots of notes on this course. The reason I highly recommend this is because you're not always going to be able to watch my video again and again, and there's going to be things which you won't understand. So write down notes of things you understand and also things that you're curious on or you want to answer, or confusions you have. Then you can write that down in the comments, and hopefully I'll try my best to answer them. Secondly, I also want you to try and research things that you're curious about or things you do not understand from this course. I'm going to be trying to explain to you as much as I can, but there will be things I'll miss out and things that you won't understand. So go out there and research. There's lots of resources available. Go and see other YouTube videos about the things that you're curious or stuck on, and write it down. You can write that down in the comments, and I'll try to answer them. Finally, I also would like you, if you can, to subscribe to the channel. This will support my channel, but also if you click the bell button, it will give you an email of when my new videos release, so you can keep up with the series, and my video is much more likely to appear on your recommended list. So in case you forget, you won't miss out on any learning opportunities. So without further ado, I'll get on with the rest of the course. So the first characteristic for defining cloud is elasticity and scalability. These two go hand in hand and are extremely important. So as you can see here, I've drawn a small graph for you. I'll just quickly rub out the underlines there. So in this graph, as you can see, we've got resources on the y-axis and time on the x-axis, and we've got demand and capacity. So I'll quickly define what this is and how you can use this to benefit your corporate business or your home office, whatever you're using. So the demand and capacity, these two need to, as the demand fluctuates, the capacity needs to cope, and this is where these two terms come in. You see, as the demand for cloud technologies and new technologies in a certain area or the entire general field increase, so does the capacity for cloud to implement that. And when it decreases, the demand decreases, the capacity also needs to decrease and manage with the changes happening. That's some horrible handwriting. Yeah. So this is how we can define elasticity. So elasticity is right here in the graph, where, as you can see, the capacity is increasing. So fundamentally, elasticity is as the this is scalability. Elasticity is right here. So as the demand of resources shrinks, so does the capacity for cloud to implement it. So I'll just write that here. Elasticity. So as the demand decreases, I'll just write D for decrease. Capacity also decreases. I just use these acronyms quite a lot here. Secondly, we have scalability, the mistake I made here. So scalability is as the demand for resources increases, so does the capacity for us to use it or cloud to implement it. So I'll write it here, scalability is as the demand increases, so does the capacity. Actually, you know what? I'll use an arrow here to make it nicer. Yeah. So, as we can see, these two, you may be asking me, they may not have a significant role, but they do have a very significant role, and it's very important that we understand both of these to use cloud to the fullest. So elasticity and scalability, these two go hand in hand, and we need to understand this to move on. So if you do not understand this, rewatch this video, rewatch this part of the video, and if you still have any questions, just write it down in the description below. I'll write that here for you as well. So write those down in the description, and hopefully I'll answer them for you. So now we move on to the second characteristic of cloud, which will be about cloud being on demand. Hi guys, so this is me from the future, and I just realized I had to explain two other points when I was editing this video. So first is going to be availability, and the second is going to be reliability. You know, they got this ending, so it might be a bit easier to understand. So you might already know what these are, but just to recap what they are if you don't know. How to spell reliability? Okay, yeah. So reliability is how reliable a source are. So it's like when you're seeing an advert for cloud, if it's not a well-known company, you're less likely to click it, right? But that's because you find them less reliable. So we want to make sure our cloud resources are reliable enough for us to use them, so they won't just make us purchase it, then just run away with all the money they got. I also want to make sure that they're available to everyone. So they're not always crashing. They got good quality. We can use it in different locations. So, say for example, I was on the North Pole once again, and I was on the North Pole. I'll write this down in red. So the North Pole, I still want my resources to be available in the North Pole. It's a bit of extreme example, but it helps you understand it better. So these also go hand in hand. I want you to remember these because they're very important, and whenever you're buying or purchasing a cloud resource, I want you to pay attention to these two, so you make sure what you're getting is worth your money. So here we are. As you can see, there's no illustrations to help you. I'll just be purely talking and writing at this point. So on demand, well, when you think about it, you may just be thinking about a king. They can get whatever they want on demand whenever they want to have it. Well, it's a bit different here, but it's a similar concept if you want to think of it in that way to help you remember it. So on demand fundamentally means that we can use cloud when we can leverage cloud technologies whenever we want. Now, to understand this, I want to quickly show you something about virtual machines. Now, virtual machines, we have an acronym for it called VM. I'm going to use it a lot here. And we can run VMs on our actual machine, but they take up live resources. So these are things like RAM, CPU, GPU, memory, etc. So you know, all the things that when we're searching to buy a laptop, well, we take notice of, and you should take notice of this when you're getting a laptop or whatever electrical appliance you're getting. So the thing is, the VMs do not use much of these, as you may think. So if a VM's got 8 gigs of RAM, you're like, oh my gosh, it's taking up 8 gigabytes of RAM for my actual machine. I've just lost a lot. Well, don't be. It's probably taken a lot less because this virtual machine is using virtual memory, and there's a lot to this field. So you don't need to understand it yet, but fundamentally, it's going to be using a bit of your live resources, but not a lot as you expect to get this actual value right here. The second thing about on demand is that, as it suggests, we can use it whenever we want. So the main thing that will benefit from this is cost savings. Now, this is because when we're running a virtual machine 24/7, we're just going to be having to pay for it every single second. We have to be paying for the software which is running it. So we also have something called subscriptions, which I'll explain later. But the thing we need to understand is that we've got major money cost saving capabilities with running on demand virtual machines. And the benefit of this is that, as it suggests, you're wasting less money on when you're not using it. So let's just say my VM is running at night and I only use it for about 1 hour in a day. So we've wasted 23 hours. So instead of paying for 1 hour, we're also paying for the other 23 we've kept it on. So this will be, as you can see, it's going to give us major cost savings in the long term and in the short term. So next I'll be showing you a diagram of an actual VM. So here we are on a virtual machine example. So as you can see, this is a Ubuntu device 64-bit used on VMware Workstation. So as you can see, this device has been using live resources. So we've got 4 GB RAM, we've got 4 processors, we've got 22 GB on the hard disk, we've got we've got all these things. And these are using live resources, but not, as I said, not as much as you actually expect due to other factors such as virtual memory and other things. So I just write that not as much as you expect. So the main thing I want to take away from this is subscription. So in this example, I don't have a subscription on here. Well, I may have, but actually no, I don't. I have a subscription on it, but you can't see it right now. So what a subscription basically is the payment, or how you'll actually pay how much you use for that device. So let's just say I use my device for 24 hours every single day. I doubt many people do that, but let's assume that my subscription, depending on what it is, then will decide when or how much I pay for it. So if it's a monthly subscription, for example, I'll pay my monthly fee after I've been using this 24 hours every day for a straight month. Other subscriptions, such as the pay-as-you-go, is incredibly useful. So as I'll change the color, it's a bit hard to read on here. So as I use this device, I pay once I have finished. So once I've run my device and I've probably used it for, like, let's see, an hour, I'll pay for 1 hour of use as soon as I finish. I don't have to wait for the end of the month or the end of year, whatever, for me to finish and just pay the fee or find out how much it is. So I use it for 10 seconds, I pay 10 seconds fee. I use it for 1 hour, I pay 1 hour fee. So this has got its benefits and disadvantages. And one of the benefits of this is the fact that you don't have to be worrying about, well, what's my fee? How long have I been using it? You just know straight away after you finished. But the disadvantage of this, actually, you know what? There's not actually much disadvantage to this. The ones I found out aren't really true. So currently, there's no disadvantage. Just put it that way. So here we are at the resource pooling. Now, many companies such as Microsoft and Amazon have actually paid to do this. So many big companies, they've invested into this. Now, before, remember I was telling you about VMs and them being on demand, and I had that slide before showing you it. So this right here what I've got is a blade server, and a blade server fundamentally is just a machine really, which is for storage and for other uses, but let's just focus on it for now as something used to make VMs. Now, usually this will be in a chassis, which we use to store blade servers and other things. So we have blade server here, a blade server here, and then we'll have several power units here. Now, one thing I want you to remember, and I really want you to make a note of this, is redundancy. Actually, you know what? I'll write that in red to make it more clear. Oops. It appears I've not changed the color. Yeah, no. So redundancy is simply a backup. That's the simplest I can put it. So it's in case of a failure, which happens a lot on cloud since it's very open to the public and everyone can basically use it. In case of a crash, we've got backups, so we can repair it. So in this case, let's just use our power units. Let's just say we're actually just using 2 of these, and we've got 1 spare. So in case one of these breaks, we can use this just in case. So our data is not going to have to be erased, and we don't have to sacrifice anything here. So that's the main benefit of having redundancy. Secondly, I want to explain the actual factor of resource pooling. So resource pooling is basically when we can use this blade server or other device to run several VMs on it. Since when we're running a VM, we need an actual physical device. So on one of these blade servers, I can run several VMs. So think about when I've got an entire chassis, and that's inside of a building. So I'm talking in case of like lots and hundreds, maybe chassis. We can run as many VMs as we really want. So this has got lots of capabilities. So resource pooling is fundamentally when we are using several devices to run VMs. So we can run virtual machines with several devices. That's fundamentally and simply what it is. Now this is something more onto the price side. So if you're thinking about how this will affect your company or your home office, and you want to know how much you actually have to buy and how easy it's gonna so you don't get frauded or whatever it is, we can use something called measured service, which is quite popular in the world of cloud. So simply, measured service is our service, or how much we have used the service, so our cloud vendor, how much we have used them. So what is the price range that we have? So I'll quickly just rub this part out for you guys. Yeah. So oops. So as we can see here, we have got a monthly subscription, and this is the monthly amount we need. So in this case, I've used this VM or several VMs so much to the point where I have to pay this much in terms of money. Now, one of the things that we'll see on Amazon Web Services, which is what I'm using here, is that we see a pie chart and a graph showing us what services we used. So what services we used and how much we used them. So we know where we spent the most money. So let's just say here I use CloudFront the most, and other services I've used the least. So Glacier, S3, Route 3. Look, the benefit of this is that we know what we have spent it, so we know what we are using. I'll just write that down. We know what has been used and to what extent as well. So we know here that we've been using the CloudFront the most, and we may not have wanted to use CloudFront or certain technology to that extent. And so you may be questioning, well, one of my employees may be using that one, I don't want them to. And that's where it really comes in handy. So we have several capabilities with this. So we can track which employee has been using which one and for what reason, if we can ask them. And we can also find out what the other services are if we go more depth in it. So this measured service just makes our lives easier and makes it easier for us to find out if someone's using services on cloud which we do not want them to. And then next and finally, we are going to have broad network access. Broad network access is simply how available the service is to everyone in a global scale. So I'll write that down. Globally, how accessible it is. So this is going to be Google, and we're just going to show you all the servers. So all these blue dots here is equivalent to one server, so I'll do that here. Yes, my illustrations aren't that good, so this is going to be one server. Now, as we can see, most of their servers are set out in the northern areas, so in more rich countries, so such as the UK, Europe, America, South America. We've got a bit in Australia, we've got a few in Africa, we've got a lot in Southern Asia. So now we know that where we might want to settle with our businesses. So the thing that you want to know, the closer you are to a server, the better quality you'll get of your cloud. So the better communication you get with cloud. The better communication. Oh, you just want to note that down. So the better communication we get with cloud, it makes it easier and more effective for us to accomplish our our tasks. So let's just say I've set up my my company's home office in the North Pole, for example. It's quite extreme, but we'll use it for now. And the closest right here, as you can see, is all the way there in Europe. So it's much smarter for us to set it up somewhere like Norway, for example. So I'm not sure that's green. Sorry, Greenland, as you're closer to the servers. And if you're in areas such as this, it'll be harder for you to communicate with the server. So it won't be harder, but it'll be more difficult for you to reach it. And if you're on a remote island like this, it'll be all the way there. Now, broad network access, I'll just explain a bit more, is how accessible it is for us to use cloud from our current location. So something I want to really remember is open standards. Now this is moving a bit away from the broad network access, and I'm writing this in red so you definitely remember this. I want you to remember open standards and web-based open standards. These two are key. So open standards is simply how freely we can change things, so our standards. So you may ask what a standard is. Let's just say we've got two shops. Okay, this is shop 1 and this is shop 2. I'm just doing this to help you understand it. So when we connect to the Wi-Fi of shop 1, it's a certain layout, and we connect to the Wi-Fi of certain shop 2, it's another layout. That'll be difficult for us to access. If we use the shop 1, it's going to be difficult for us to use the GUI to connect to the Wi-Fi of shop 2, which makes us more accustomed to staying with one thing. Now, cloud, we want everyone to be able to access it. So open standards is when we've got a certain format which we usually use, and we're freely able to change that, so we're allowed to add our own twist, but we've got a template of what we usually use. So when you browse the web, for example, I'll use that, you've got universal icons. So whenever you hear a sharp noise, you usually know that's an error. whenever you see this I, for example, it usually shows us information, a question marks for help, etc. So this, we've got a template of it, but as you can see, different companies that add their own little twist, so we can still understand the basic what it is, but we've got our own little twist to it to make it more unique, but it's still accessible to everyone else. Now, web-based open standards, I'll change the color to make it easier to understand. It's basically the same thing but web pages. So we've got a similar design for everything. So this is my illustration of the search bar. So we're going to have a template, a really basic template of what it's going to look like, and we can. And with web open standards, web page open, we have a lot more freedom to change it about than, let's just say, our Wi-Fi. And that is really it for this video. Don't forget to subscribe to support the channel, and to also comment down below with any questions. I'll try my best to answer. Like the video if you enjoyed it, and also click the bell button so whenever I release a new video, you always know when you have two ways to check it. So you got your email, and it's usually on your recommended list. So that is it from me today. I'll be releasing the next part of this series hopefully next week.